Hi, everyone. My name is Robert Fiore. I'm a high school mathematics teacher at Loyola School in New York City. I started at St. John's University in 2016 and completed the Advanced Certificate Program in School Building Leadership and School District Leadership. I applied those credits to the EDD program in Administration and Supervision at St. John's University. I defended my proposal on October 9th, 2019, and defended my final dissertation 5 months later on March 9th, 2020. I graduated in May 2020, and here is the presentation I used during my final dissertation defense. The Advanced Placement Program allows high school students to learn college-level material which culminates in a standardized exam, usually administered in May. Depending on the student's score on that exam, he or she may be eligible to receive credit from undergraduate institutions and or be exempt from taking certain courses. The student receives an integer score from 1 to 5, with 5 being the maximum possible score. The Advanced Placement or AP program is one of the most common ways that the United States provides advanced academic content to talented and motivated high school students. The AP program is important to study because it has been shown to have a number of positive outcomes for participants compared to non-AP students. They score higher on standardized exams, have higher college attendance rates, earn higher grades in college, are less likely to drop out of college, graduate from college in higher proportions, and possess more positive attitudes towards the same academic content covered by their AP course, and are more likely to study a field pertinent to the AP course. The current study explored the influence of the amount of instructional days and amount of instructional time in minutes on high school students' scores on the AP Calculus AB and BC exams. The purpose of this non-experimental research was to ascertain the influence of the amount of instructional days and the amount of instructional time in minutes on achievement on the Advanced Placement Calculus exams for students from various high schools in the United States. Differences in the amount of instructional time or amount of instructional days can occur due to the month that the district starts the school year or the hours or schedule that the high school operates on each day. The study has implications with new instructional methods, as teachers may need to reevaluate their practices in order to foster student success in the exams. Moreover, the study has implications with policy changes. Specifically, if there is a positive association between the amount of instructional time and scores on the exams, school districts may be encouraged to begin their school year earlier. The present study related to the theoretical framework of constructivism, because the amount of instructional time and amount of instructional days influenced how well students constructed knowledge and consequently performed on the AP Calculus exams. Constructivism is the lens through which research problem research questions are evaluated. Constructivism is a philosophical explanation pertaining to the nature of learning. There is a connection between constructivism and type of scheduling in the school, which in turn influences the amount of instructional days and amount of instructional time. In the current study, the researcher took note of the amount of instructional days, amount of instructional time, and the type of scheduling that each school operated on. The physical and social context of the in-person classroom, meeting for a certain number of days and minutes, will lead students to construct knowledge. More instructional time would facilitate students' construction of knowledge. The conceptual framework in Figure 1.1 explains how the amount of instructional days and amount of instructional time influence how students construct knowledge, which in turn impacts performance on the AP Calculus examinations. Insight is needed to better understand how the quantity of instruction impacts student learning. The researchers' conjecture is that there was an association between the amount of instructional days and amount of instructional time and performance on the AP Calculus exams. An important educational research topic is best instructional methods and practices for high school and undergraduate mathematics courses. As the literature review will articulate, an increase in instructional time had either a positive or neutral influence on student performance. The current research study will extend past research by demonstrating that the relationship between the amount of instructional days and amount of instructional time in AP exam performance is either neutral or positive. The current research study will fill in a gap in the existing literature by focusing on the impact of instructional time on the AP Calculus exam, which has not been a focus in prior research. There are several practical problems and issues which focus the current study. The national passing rate for AP Calculus AB in 2019 was 58.3%. The mean score was 2.97, which is lower than a qualifying score. Since some states start school in July or August and the AP exam is in May, some states have more instructional days before the AP exam. This can lead to more review for the exam, deeper learning, and an increase in student learning and achievement. This is the first research question. The three independent variables are amount of instructional days, amount of instructional time, and class type. The dependent variable is AP Calculus exam scores. And here are the hypotheses. It covers the main effects, the two-way interaction, and the three-way interaction. And here is the second research question. So the three independent variables are amount of instructional time in minutes, the school type, and the class type. The dependent variable is AP Calculus exam scores. And here are the hypotheses, again covering the main effects, the two-way interactions, and the three-way interaction. And here is the third research question. And here is the hypothesis. Here are the definition of terms. So with the amount of instructional days, I took a look at how many school days each school in the sample had. So the highest 1/3 were in the high category, then the following 1/3 were in the medium category, and the bottom 1/3 were in the low category. And I did the same kind of grouping, same style of grouping with the amount of instructional time in minutes for the schools in the sample. Type of school is either public or private, and the course is either the AP Calculus AB class or the BC Calculus class. There appears to be a hole in the current educational research, namely on why some schools start before Labor Day and others start after Labor Day. I found after attending the Advanced Placement Annual Conference that different states start school in different months. Since some states start school in July or August, one can assume that those schools have more instructional days before the AP exam in May. In turn, those schools could have more instructional time before the exam. Thus, the main focus of the literature review was on the amount of instructional time in schools. By investigating such research, there was more context for the findings. The research suggests that increasing instructional time has a neutral or positive influence on student achievement. Kedron and Lindsay's 2014 study aligned with other research in the literature review, namely that it is not just about an increase in instructional time that matters, but also what happens in the classroom in conjunction with the added instructional time. These concepts also pertain to the conceptual framework of constructivism discussed in the first chapter. Students construct knowledge based on the frequency of class time and or scheduling, and that knowledge is constructed in the physical and social context of the classroom. Here lies the bridge or connection between the independent variables, which is the amount of instructional time and amount of instructional days, and differences in the dependent variable, which is performance on the AP Calculus exams. The researcher has attended the Advanced Placement Annual Conference for 3 summers, which is a convention of AP teachers from across the United States and spanning all of the advanced placement courses. The school day length and year change over time and across localities, which was a finding supported by the attendees of the Advanced Placement Annual Conference. Proponents claim that more time will have learning benefits as well as non-academic benefits. Critics suggested that more time could be costly and is not guaranteed to lead to higher quality instruction. Based on the literature review, looking at scores in the Advanced Placement Calculus exams based on when schools start the year lent itself best to a statistical analysis. The research in the literature review would likely support the alternative hypothesis that there will be a statistically significant difference between AP Calculus exam scores based on the number of instructional days and amount of instructional time in minutes. The amount of instructional time was important to study for the literature review as it provided insight on additional topics that could be examined related to education systems. The start date of the school year may end up not having an influence on the scores. The disparity between scores could reveal educational inequities between the states, which align with the prior research on the importance of accountability. Charts from the College Board also signified that there was generally a discrepancy between the performance of certain minority groups in comparison to state and national averages. In the current study, the school with the highest percentage of minority students had the lowest average score. The type of school, public or private, is pertinent to the second research question in the current research study. In 2014, private school students accounted for 11% of the AP exams taken by United States students in private and public schools. A 3 is the minimum score on an AP exam that can possibly earn a student college credit. The percentage of public school students who scored 3 or higher on an AP exam in 2014 was about 57%. By contrast, The percentage of private school students who earned at least a 3 on an AP exam was 71%. Moreover, the average AP score for private school students was 3.24 in 2014, and the mean score was 2.82 for public school students. Thus, the research here would likely support the alternative hypothesis that there will be a statistically significant difference in AP Calculus exam score based on the amount of instructional time and the school type. The percentage of AP Calculus AB and BC students in the school who took both the course and the exam is pertinent to the third research question. In 2014, the ratio of AP exams to students was 37% for private schools and 24% for public schools. While there is plenty of national and state data available on AP exam scores, there does not appear to be much peer-reviewed literature on the percentage of students taking an AP exam from within individual schools. Since the current study focused on the percentage of AP Calculus AB and BC students who took both the course and the exam out of the entire school population, the study helps fill in another gap in the current research. The literature review conveyed that increasing instructional time did not have an adverse impact on student achievement. The literature showed that in some instances the effects were neutral, but in the remaining studies the results were positive. There were no findings in the literature suggesting that increased instructional time led to a decrease in student achievement. Moreover, the literature review conveyed that the effectiveness of the increased instructional time worked in conjunction with a number of other factors. Such factors include, but are not limited to, gender, motivation, socioeconomic status, accountability measures, budget autonomy, instructional quality, and teachers' ability to make use of the additional time. For the first research question, the amount of instructional time in minutes and amount of instructional days were numerical. The type of class, AB or BC, was categorical. The advanced placement calculus scores were the dependent variable. A three-way between subjects analysis of variance, or ANOVA, was utilized to answer the first two research questions. Before the three-way ANOVA was conducted twice, descriptive statistics were calculated for AP calculus scores based on the amount of instructional days, number of instructional minutes, school type, and class type. While mean differences can easily be computed from a table, a one-way ANOVA was conducted to determine if any of the pairwise comparisons for the amount of instructional days and number of instructional minutes were statistically significant. In addition, independent sample t-tests were conducted to ascertain if the mean differences between class type or between school type were statistically significant. A multiple linear regression was utilized to answer the third research question. An alpha level of 0.05 was used for the analysis in each research question. The purpose of this non-experimental research was to determine the influence of the amount of instructional days and amount of instructional time on student achievement in mathematics, just scores on the AP Calculus exam. The design was non-experimental since the researcher was utilizing data from an exam that had already taken place, the AP Calculus exams from May 2019. The sample consisted of students enrolled in AP Calculus at high schools throughout the United States. The researcher ensured that the minimum sample size requirement for a correlational study were satisfied. The researcher provided demographic information about each school in the sample, as well as about all schools in the sample. The course is usually taken by 11th and 12th graders, so the students are normally between 16 and 18 years of age at the time of the AP examination. The target population was high school students with similar demographics and AP Calculus students. The accessible population was the AP Calculus students in the schools that the researcher was able to gather data from. In addition to personal networking connections, the researcher had contacted the College Board and posted on an AP Calculus forum for teachers. Teachers responded from different states around the country and were willing to share data. Archived data was used. The AP Calculus examination scores was the dependent variable being analyzed. The AP Calculus exam is a cumulative and summative examination graded on a numerical scale of 1 to 5. The assessments can be considered norm referenced as the AP exam is curved, and the College Board tries to ensure that roughly the same percentage of students are earning a qualifying score each year, which is 3 or higher. The target goal is for the student to pass, again, 3 or higher. The assessment aligns with the AP curriculum and standards set forth by the College Board. AP Calculus AB is considered the equivalent of Calculus 1 in college. The AP Calculus BC assessment covers all the topics from the AP Calculus AB exam, as well as several additional topics. AP Calculus BC is considered the equivalent of Calculus 1 and 2 in college. The assessment helps to test standards needed for success in college calculus courses. The breakdown of the AP Calculus A, B, and BC examinations is the same. The score out of 108 points is then converted to the student's AP exam score from 1 to 5. Students who take the BC Calculus exam also receive a sub-score from 1 to 5 for the AB exam. The range of scores that constitute a 1, 2, 3, 4, or 5 varies slightly from year to year. Once again, the College Board tries to ensure that a similar percentage of students are earning a qualifying score each year, which is 3 or higher. Similar format examinations for AP Calculus A, B, and BC have been used for years by the College Board. The exam has been considered a valid predictor of student performance in college calculus courses. The assessment has also been a good indicator for where students should be placed in mathematics in college. Students scoring at least a 3 on the AP Calculus A-B exam may end up placing out of Calculus 1 and into Calculus 2. Those students with a 3 or higher on the AP Calculus BC exam may end up placing out of Calculus 2 and into Calculus 3. The AP Calculus A, B, and BC exams are reliable, as there have been similar passing percentages for each exam in recent years. There was no treatment or intervention. The AP exam scores are disseminated to the schools in early July. The multiple choice is scored by a machine. Teachers meet during a set week in June to grade the constructor response questions. Teachers must apply to be graders for the exam, must have taught the course for at least 3 years, and must have taught the course in the previous school year. The teachers go through an extensive training process to ensure that the scoring rubric is being correctly followed. Doing so helps ensure consistency and accuracy with scoring for each student. If a teacher is unsure about the score that should be assigned to a student, he or she may consult with a colleague grading the same question. Each constructor response question is a table leader who is an expert on the rubric for that particular question. The teacher can also run a question about the grading with the table leader. Thus, there is a professional who is there to provide support to the teachers during the grading process. The researcher gathered the AP exam scores from schools who are willing to share their data. Any data files were kept on the researcher's password-protected email account to help ensure security. The assessment and administration met the guidelines for protecting human subjects. Approval to use the assessment data was given to the researcher by a building administrator. Confidentiality was maintained as no names or other identifying information was used in the collection of data. The assessment was appropriate for measuring the intended variables. The assessment was selected because it was considered valid and reliable by both the schools using it and the College Board. So just to quickly go through the results. So a 3-way between subjects analysis of variance, or ANOVA, revealed that there was a statistically significant difference in AP Calculus scores based on the amount of instructional days, the amount of instructional time in minutes, and the class type, AB or BC. There was not a statistically significant difference in AP Calculus scores based on the school type, public or private. A multiple linear regression revealed that the amount of instructional time in minutes, class type, AB or BC, and the percentage of students who took both an AP Calculus course and exam were statistically significant contributors towards the linear model predicting a student's AP Calculus score. The amount of instructional days and the school type, public or private, were not significant contributors towards the same linear model. The results were important in that they justified the theoretical framework of constructivism. Relevant implications include the support for school districts to increase the amount of instructional time and minutes for the school year. Here are the implications of findings and the relationship to the prior research. Here are recommendations for future research and future practice. There are limitations of the study. So I thank you all for attending my presentation. Everyone have a great day and enjoy the rest of the symposium.